Melting ice cores on frozen worlds could speed up the search for alien life. The search for life beyond Earth has always been a tantalizing prospect for scientists, and with new technological advances and exploration missions, the possibility of discovering extraterrestrial life is becoming more possible. However, the search for life on other planets has been largely limited to the search for liquid water, a crucial ingredient for life as we know it. But now, melting ice cores on frozen worlds could speed up the search for alien life in ways we never thought possible. But what does this mean? And is there any indication of life on other planets? The frozen worlds in our solar system include planets such as Mars and the moons of Jupiter and Saturn. These planets are believed to have liquid water beneath their icy surfaces, which is a crucial ingredient for the existence of life as we know it. These icy surfaces can provide valuable information about past climates, atmospheric conditions, and the atmosphere's composition at different points in time. They also contain microbial life that can be studied to understand how life adapts to extreme environments. On Earth, ice cores have been used to study the history of the planet's climate over the past 800,000 years. They have provided critical information on the changes in atmospheric composition, temperature, and precipitation, which have significantly impacted the evolution of life on our planets. Ice cores have also revealed the existence of microorganisms that have been frozen for thousands of years, providing valuable insights into the adaptability of life in extreme environments. But ice cores can also be used to study frozen worlds beyond our planet. The search for life on other planets has traditionally focused on planets located in the habitable zone, where liquid water can exist on the surface. However, with discoveries of frozen worlds like Europa, Enceladus, and Pluto, the search for life has expanded beyond the traditional habitable zone. These frozen worlds may not have liquid water on the surface, but could still contain liquid oceans beneath their icy shells. Melting ice cores from these frozen worlds could provide valuable insights into the nature of these subsurface oceans. The microbes that live in these frozen environments could provide clues about the potential habitability of these oceans and the possibility of life in them. The composition of the ice cores could also provide information about the geology and chemistry of these worlds, which could help us understand the conditions required for life to emerge and thrive. One of the most promising targets for studying frozen worlds is Europa, one of Jupiter's moons. Europa is believed to have a subsurface ocean beneath its icy shell, and there is growing evidence that the ocean could support life. The ice covering Europa's ocean is considered several kilometers thick, but recent studies have suggested that the ice may be only a few meters thick in some regions. This thin ice can make it easier to access the subsurface ocean and study the microbial life that may exist there. Scientists are developing ice-penetrating radar (IPR) technology to study Europa's ice. The IPR is a specialized radar system that can penetrate through the ice and map the subsurface features of Europa. It could provide valuable information about the thickness and composition of the ice, the potential locations of subsurface oceans, and other features that could indicate habitability. Scientists also have another technology up their sleeves, the Melter-Sublimator for Ice Science, MSIS, which promises to revolutionize our understanding of planetary bodies and even help us better understand supernovas and space weather. The MSIS is a specialized tool designed to examine ice cores for chemical, biological, and elemental analysis. By melting and sublimating ice samples, it can provide a detailed record of the composition of planetary bodies, including information about their geology, past climates, and potential habitability. The MSIS works by melting ice samples in a high-temperature furnace, which causes the ice to vaporize. The vapor is then collected and analyzed using a mass spectrometer to determine the composition of the ice. This technique allows scientists to identify trace elements and isotopes, which can provide valuable information about the history of the planetary body in question. The MSIS could help us identify potential habits for life beyond Earth by analyzing ice cores for biological compounds. For example, amino acids, the building blocks of life, would strongly indicate that life may exist or have existed on a particular planetary body. The MSIS can also help us better understand the history and evolution of our solar system. By examining ice cores for cosmogenic nuclides, rare isotopes created by cosmic rays, scientists can determine the age of the ice and gain insights into the timing and intensity of past space weather events. These events, such as supernovas and solar flares, can significantly impact the habitability of planets and moons. In addition to its potential applications in astrobiology and planetary science, the MSIS could help us better understand how our climate has changed over time and how it may continue to change in the future. The MSIS is still in development, but it has already shown great promise in laboratory tests. In a recent study, scientists used the MSIS to analyze ice samples from the dry valleys of Antarctica, some of Earth's oldest and driest ice samples. The study results show that the MSIS could detect trace elements and isotopes at levels previously thought to be undetectable. The potential applications of MSIS are vast and exciting. From searching for signs of life on other worlds, to improving our understanding of the history and evolution of our solar system, the MSIS has the potential to revolutionize our understanding of the world around us. As we continue to explore and study other worlds, tools like the MSIS will be critical in helping us unlock the secrets of the cosmos and uncover the mysteries of life beyond Earth. Enceladus is believed to have a subsurface ocean beneath its icy shell, and recent studies have suggested that the ocean could be habitable. In 2017, the Cassini spacecraft detected the presence of hydrogen gas in Enceladus's plumes, a potential indicator of hydrothermal activity in the subsurface ocean. Hydrothermal activity could provide the energy and nutrients necessary for microbial life. To study Enceladus's ice, scientists are developing a technology called the Enceladus Life Finder, ELF. The ELF is a proposed mission to land on Enceladus and collect ice core samples from the moon's surface. The samples would then be analyzed for signs of microbial life, including DNA, RNA, and proteins. The ELF mission could provide critical insights into the potential habitability of Enceladus and the possibility of life existing in its subsurface ocean. Pluto, once considered a distant and cold dwarf planet, is also emerging as a potential target for studying frozen worlds. In 2015, NASA's New Horizons spacecraft flew by Pluto and discovered that the planet had a geologically active surface and a nitrogen-rich atmosphere. Recent studies have also suggested that Pluto may have a subsurface ocean beneath its icy shell, which could be similar to the oceans on Europa and Enceladus. The study of ice cores from frozen worlds is still in its infancy, and there are many challenges that must be overcome to make it a reality. The harsh conditions on these frozen worlds make it difficult to design missions that can penetrate the thick ice and reach the subsurface ocean. Extreme cold and radiation also pose significant challenges to the survival of any potential microbial life. However, advances in technology and exploration missions are bringing us closer to the possibility of studying ice cores from frozen worlds. The development of specialized radars, drills, and landers makes it possible to penetrate the thick ice and reach the subsurface oceans. The discovery of hydrogen gas in Enceladus's plumes and the detection of a subsurface ocean on Pluto also provides strong evidence for these worlds' potential habitability. Studying ice cores from frozen worlds could be a game changer in the search for alien life in the universe. It could expand our understanding of the conditions required for life to emerge and thrive, and provide critical insights into the potential habitability of these worlds. It could also help us answer some of the most fundamental questions about our place in the universe and the possibility of life beyond Earth. That's all from this video. Do you think there is life beyond Earth? See you at the next one.